As if the solar system couldn't get any more fascinating, a brand new study suggests that oceans of water may be hiding within planets Uranus and Neptune.
So we don't know much about them. And when we did go by, when we sent probes in the 80s, we found that they behaved, especially their magnetic fields were really odd. So it told us we didn't understand what was going on inside.
Are quite visible to the unaided eye at night. So no one person is credited with any of their discoveries. Cavemen saw these planets.
The auditorium lights dimmed as
For centuries, we've gazed at the outer reaches of our cosmic neighborhood, assuming we understood the worlds that drift in the cold, silent void. But on a quiet morning in a bustling research facility, a team of astronomers stumbled upon something that shattered every textbook, every model, every assumption about what a planet can be. A distant world, far beyond the reach of our sun's warmth, revealed a secret so staggering it could rewrite the very definition of planetary science. Deep within its core, something inexplicable was happening. Signals, structures, and behaviors that defy everything we thought we knew. This wasn't just an anomaly. It was a cosmic wake-up call, a whisper from the universe that our understanding of planets is far from complete. What could be hiding inside this enigmatic giant, and why is it challenging the foundations of everything we believe about the cosmos? Before we unravel this mystery, smash the like and subscribe buttons for more updates on the universe's greatest secrets. The story begins decades ago, when the first probes ventured into the outer reaches of our star system, mapping distant worlds with crude instruments that could barely scratch the surface of their mysteries. These planets, cloaked in thick atmospheres and battered by relentless cosmic forces, were thought to be simple, gas giants or icy behemoths, their interiors governed by predictable physics. But as our technology evolved, so did our ability to peer deeper, to see beyond the swirling clouds and into the heart of these celestial titans. By the early 21st century, advanced observatories, both in space and on the ground, began capturing data that hinted at something extraordinary. A planet, orbiting a dim star far from our own, was behaving in ways that didn't fit any known model. This world, a massive sphere dwarfing our own, was first observed through its faint infrared glow, a signature so subtle it was almost overlooked. But in a routine scan, astronomers detected an anomaly, a pulse of energy that didn't match the planet's expected profile. It wasn't just a blip, it was a rhythmic, almost deliberate signal, emanating from deep within the planet's core. The data was clear. Something inside this world was generating heat, movement, and electromagnetic fluctuations in ways that defied conventional planetary science. The discovery sent shockwaves through the astronomical community as teams scrambled to analyze the data, their instruments humming with the weight of a potential paradigm shift. What made this anomaly so unsettling was its complexity. The planet's magnetic field, expected to be a stable dipole like those of other gas giants, was anything but. Instead, it was in a state of cyclical flux, oscillating with a rhythm that suggested an internal dynamo unlike any we'd seen before. The field wasn't just tilted, it was dancing, shifting in ways that hinted at a chaotic, dynamic interior. Scientists began to suspect that the planet's core wasn't a dense ball of rock or metal, as we might expect, but something far stranger. A region of exotic materials, perhaps even plasma-like substances, generating heat and electricity in ways we couldn't yet comprehend. As researchers dug deeper, they found evidence of warm internal regions, areas where temperatures soared far beyond what traditional models predicted. These weren't the result of atmospheric heating or stellar radiation. They were coming from within, as if the planet itself was alive with some unknown process. Spectral analysis revealed traces of superionic materials, ices under such extreme pressure that they behave like both solids and liquids, conducting electricity like a metal. Could these materials be the key to the planet's bizarre behavior? The data suggested that these superionic layers might be creating resonant chambers, cavities within the planet's interior that amplify its magnetic and thermal signatures. The idea was almost unthinkable, a planet that was partially hollow, its core a labyrinth of exotic matter and energy. The implications were staggering. If this planet's interior was indeed structured this way, it could challenge the very definition of what a planet is. Was it a gas giant, an ice giant, or something entirely new, a transitional world caught between the realms of planet and star? The possibility sent astronomers back to their models, questioning whether our classifications of exoplanets, those distant worlds orbiting other stars, were fundamentally flawed. If this planet could harbor such exotic properties, what else might be out there, masquerading as something familiar? The discovery didn't stop there. Radio emissions, faint but unmistakable, were detected emanating from the planet's depths. These weren't the random bursts of cosmic noise we'd expect from a typical planet. They were irregular, patterned, almost as if the planet was broadcasting a signal. The frequencies didn't match any known natural phenomena. No solar wind, no stellar flares, no atmospheric storms could account for them. Scientists began to wonder, could these emissions be the result of some internal process we'd never encountered, or was something else at play? The idea was too radical to voice aloud, but it lingered in the minds of even the most skeptical researchers. What if this planet was more than just a geological oddity? To understand the scale of this mystery, we need to step back and look at the timeline of discovery. Decades ago, when our instruments were less precise, this planet was cataloged as just another distant giant, its properties assumed to fit neatly into existing categories. But as new telescopes came online, their sensors capable of piercing the cosmic dark with unprecedented clarity, the anomalies began to pile up. By the 2010s, ground-based arrays had detected faint irregularities in the planet's albedo, its reflective brightness, suggesting changes in its atmosphere or surface that couldn't be explained by weather alone. These early hints were dismissed as noise, but they planted the seeds for what would become a scientific revolution. Fast forward to recent years, when next-generation observatories began probing the planet's magnetic field in greater detail. The data was astonishing. The field wasn't just fluctuating, it was cycling through phases, as if driven by an internal engine. Computational models suggested that the planet's core might contain resonant chambers, cavities where pressure waves and electromagnetic fields interacted to produce the observed signals. These chambers, if they existed, would require a complete rethinking of planetary formation. Could a planet form with hollow regions, or were these the result of some cataclysmic event in its distant past? The questions piled up faster than the answers. One theory, bold and controversial, began to gain traction. The planet might represent a transitional class, a world caught between the familiar categories of planet and brown dwarf. Brown dwarfs, often called failed stars, are massive enough to fuse certain elements, but not enough to ignite as true stars. Could this planet be a hybrid, its interior a chaotic blend of stellar and planetary processes? The presence of superionic ices and plasma-like materials supported this idea, as these substances are more commonly associated with the extreme conditions inside stars. If true, this discovery could force us to redraw the boundaries between planets and stars, blurring the lines of cosmic classification. The planet's wind systems added another layer of intrigue. Unlike the atmospheric storms driven by solar heat on other giants, these winds seem to pulse with an internal rhythm, as if fueled by thermal bursts from the planet's core. Observations showed jet streams accelerating and decelerating in sync with the magnetic field's oscillations, a phenomenon that hinted at a deep connection between the planet's interior and its atmosphere. This wasn't just a planet, it was a dynamic system, a living machine of gas, ice, and energy, operating on principles we were only beginning to grasp. As the scientific community grappled with these findings, a sense of humility began to set in. For centuries, we've built models to explain the cosmos, assuming our tools and theories could capture its complexity. But this planet was a reminder that the universe is vast, unpredictable, and full of surprises. Each new observation forced us to question not just our understanding of this world, but of every world we've ever studied. If a planet could harbor such exotic properties, hollow chambers, superionic ices, rhythmic signals, what else might we have missed in the countless worlds scattered across the stars? The data kept coming, each dataset more perplexing than the last. The planet's radio emissions, when analyzed, showed patterns that hinted at structure, sequences that repeated with unsettling precision. Were these the result of natural processes, like pressure waves in the planet's core, or something more? The question hung in the air, unvoiced, but impossible to ignore. The planet seemed to be speaking, its signals a cryptic message from the depths of space. And as astronomers pored over the data, they couldn't shake the feeling that they were on the verge of something monumental, a discovery that could redefine not just planetary science, but our place in the cosmos. Only just begun to grasp. The discovery of this distant world's strange interior has ignited a firestorm of debate among scientists, each new piece of data peeling back layers of a mystery that grows more profound with every observation. What lies at the heart of this planet? Is it a chaotic blend of superionic ices and plasma-like materials, or something even more alien? And why is it behaving in ways that no other world in our cosmic catalog can explain? The answers, if we can find them, could force us to rethink not just this planet, but the very rules that govern the formation and evolution of worlds across the universe. The planet's rhythmic radio emissions, first detected as faint whispers in the cosmic noise, have become a focal point of research. These signals aren't random. They pulse with a cadence that suggests an internal process, a heartbeat of sorts, emanating from deep within the planet's core. Unlike the steady hum of other gas giants, these emissions are erratic, shifting in frequency and intensity as if responding to some unseen force. Researchers have compared it to a cosmic orchestra, its notes discordant yet deliberate, as if the planet is trying to tell us something. The data, painstakingly collected by advanced observatories, shows patterns that defy explanation, sequences that repeat, then fracture, only to re-emerge in new configurations. Could these be the echoes of resonant chambers, vast cavities where pressure waves and electromagnetic fields collide to produce this unearthly song? The idea of resonant chambers, hollow regions within the planet's interior, has sparked fierce debate. Traditional models assume planets like this one have dense, uniform cores, compressed by gravity into tight balls of rock or metal. But the data paints a different picture, a labyrinth of low-density zones, where superionic materials oscillate under unimaginable pressure. These chambers, if they exist, could act like cosmic amplifiers, magnifying the planet's internal signals and sending them rippling through its magnetic field. The concept is almost fantastical, yet the evidence is hard to dismiss. Spectral scans reveal thermal pulses, hotspots that flare and fade in sync with their radio emissions, as if the planet's core is alive with motion. It's a vision of a world that's not just dynamic, but strangely hollow, a celestial puzzle box with secrets locked inside. Superionic materials, those bizarre hybrids of solid and liquid, are at the heart of this mystery. Under the crushing pressures of the planet's interior, ices like water and ammonia transform into a state that defies our everyday understanding of matter. These materials conduct electricity like metals, generating currents that could power the planet's erratic magnetic field. Imagine a core not of stone or iron, but of shimmering, molten ices, swirling in a dance of heat and energy. These currents might explain the planet's thermal pulses, bursts of heat that radiate outward, defying the frigid temperatures expected at such a distance from its star. But how could a planet so far from its sun's warmth sustain such activity? The answer might lie in its formation, a process that left it with an internal engine unlike any we've seen before. The planet's magnetic field, already a marvel with its wild oscillations, adds another layer of intrigue. Unlike the orderly fields of other giants, this one is in constant flux, twisting and turning as if driven by a chaotic dynamo. Scientists suspect that the superionic materials, with their electric conductivity, are generating this field, but the process is unlike anything in our models. The field's cyclical shifts, rapid changes in strength and orientation, suggest an internal system in perpetual motion, a cosmic engine that never rests. It's as if the planet is a living machine, its core a furnace of exotic matter, pumping energy into its atmosphere and beyond. This dynamo, if we can understand it, could unlock new insights into how planets generate their magnetic fields and why this one is so profoundly different. The planet's winds, screaming across its atmosphere at speeds that dwarf Earth's hurricanes, are another piece of the puzzle. For decades, we assumed such gales were driven by external forces, the faint heat of a distant star, stirring the atmosphere into chaos. But the data tells a different story. Those internal thermal pulses, tied to the superionic core, might be the true engine of these winds. As heat surges upward, it triggers convective currents that whip the atmosphere into a frenzy, creating jet streams that pulse in time with the planet's magnetic fluctuations. It's a symphony of motion, where the planet's core, atmosphere, and field move as one, a dynamic system that challenges our static view of distant worlds. As researchers probe deeper, the implications of this discovery ripple outward, touching every corner of planetary science. If this planet's core is partially hollow, with resonant chambers amplifying its signals, it could represent a new class of world, a transitional object, neither planet nor star, but something in between. Such a classification would force us to rethink our understanding of exoplanets, those countless worlds orbiting distant stars. Many exoplanets, especially those similar in size and composition to this one, are modeled after our own gas and ice giants. But if this planet defies those models, we might be misinterpreting the nature of thousands of worlds across the galaxy. Are they solid, hollow, or something else entirely? The question hangs like a shadow over our cosmic maps. The discovery also raises questions about planetary formation. How could a world form with hollow chambers or superionic cores? Was it born in a chaotic nursery of colliding debris, its interior sculpted by cataclysmic impacts? Or did it evolve over billions of years, its core transforming under the relentless pressure of its own gravity? Some scientists speculate that the planet might have once been a brown dwarf, a failed star that cooled and contracted into something planet-like. If true, its exotic properties, plasma-like materials, resonant chambers, rhythmic signals, could be relics of a stellar past, a glimpse into the blurry line between planets and stars. The idea is speculative, but the data keeps pushing us toward bolder conclusions. What makes this discovery so haunting is its challenge to our scientific humility. For centuries, we've built models to tame the cosmos, assuming our theories could capture its vast complexity. But this planet is a reminder that the universe is far stranger than we imagine. Each new observation forces us to confront our ignorance, to admit that our tools, however advanced, are only beginning to scratch the surface. The planet's signals, its winds, its magnetic flux, they're all pieces of a puzzle we don't yet understand, a cosmic riddle that demands we rethink everything we know about worlds beyond our own. As the data pours in, researchers are racing to test these hypotheses. Advanced simulations are modeling the planet's core, trying to replicate the conditions that could produce superionic ices and resonant chambers. Observatories around the globe are tuning their instruments to capture every nuance of the planet's radio emissions, searching for patterns that might reveal their source. And in the quiet corners of research labs, scientists are whispering about the possibility of something even more profound. Could these signals, with their eerie precision, hint at processes we've never encountered? The question is too bold for most to voice aloud, but it lingers, a spark of curiosity that drives the search forward. The planet's discovery has also reignited debates about our place in the cosmos. If a world so familiar, so cataloged and classified, can harbor such secrets, what else might be hiding in the vastness of space? Are there other transitional worlds, their interiors pulsing with exotic matter, waiting for our instruments to find them? Could our own solar system hold similar surprises, in the uncharted depths of its outer giants or the icy moons that orbit them? The questions multiply, each one a thread in the tapestry of cosmic wonder that this planet has woven. For now, the planet remains a distant enigma. It signals a cryptic message from the edge of our understanding. But with every observation, we come closer to unraveling its secrets, to peering into the heart of a world that defies imagination. The journey has only begun, And the universe, as always, has more to teach us than we ever dared to dream. Have never dared to dream. This distant planet, with its pulsing core and cryptic signals, is not just a scientific curiosity, it's a challenge to the very foundations of our understanding. Its exotic interior, possibly laced with hollow chambers and superionic ices, suggests a world that operates on principles we're only beginning to glimpse. As astronomers pore over the data, a new question emerges. How could such a planet exist, and what does its existence mean for the countless worlds scattered across the stars? The answers, if we can uncover them, could rewrite the story of how planets form, evolve, and perhaps even interact with the cosmos in ways we've never imagined. The planet signals, those rhythmic pulses that seem to hum with purpose, have become a beacon for researchers worldwide. These aren't just random bursts of energy. They carry a structure, a cadence that hints at something deliberate, almost communicative. Scientists have mapped the frequencies, finding patterns that repeat in cycles, only to break apart and reform in unexpected ways. It's as if the planet is speaking in a language we don't yet understand, its voice carried across billions of miles through the cold vacuum of space. The analogy is hard to resist. Imagine a message in a bottle, cast into the cosmic ocean, washing up on our shores with a story we can't yet read. Could these signals be the result of natural processes, pressure waves in resonant chambers, or something more profound? The question lingers, a spark of wonder that fuels endless debates. To unravel this mystery, scientists are turning to the planet's past, piecing together the story of its formation. Billions of years ago, when our universe was a chaotic crucible of gas and dust, planets like this one were born in violent nurseries of colliding debris. Most worlds settled into predictable patterns, dense cores, layered atmospheres, stable magnetic fields. But this planet seems to have followed a different path. Some researchers speculate it may have formed closer to its star, where intense heat and pressure forged its exotic interior before gravitational tugs sent it spiraling outward to its current orbit. Others propose a more radical idea. This planet could be a remnant of a failed star, a brown dwarf that never ignited, its core retaining the chaotic energy of its stellar origins. If true, its superionic ices and plasma-like materials might be relics of that fiery past, frozen in time, yet still pulsing with life. The evidence for this theory lies in the planet's composition. Spectral data reveals traces of elements and compounds rarely seen in typical planets, materials that thrive under the extreme conditions found in stellar interiors. These superionic ices, capable of conducting electricity like metals, could have formed when the planet was still a molten, star-like body, its interior sculpted by pressures we can barely comprehend. As it cooled over eons, these materials might have crystallized into the resonant chambers, now amplifying its signals. It's a story of cosmic alchemy, where the line between planet and star blurs, leaving us with a world that defies categorization. Could this planet be a bridge between two realms, a living fossil of the universe's early days? The planet's magnetic field, with its wild, cyclical fluctuations, adds weight to this idea. Unlike the steady fields of other giants, this one is a tempest, twisting and shifting as if driven by an internal storm. The dynamo responsible for this field is unlike any we've modeled, powered, perhaps, by the electric currents of superionic materials or the oscillations of resonant chambers. Imagine a cosmic engine, its gears made of plasma and ice, spinning in the planet's core to produce a field that dances across the spectrum. This dynamo doesn't just generate magnetism, it shapes the planet's entire behavior, from its screaming winds to its cryptic radio emissions. If we can decode this process, we might unlock the secrets of magnetic fields across the cosmos, from distant exoplanets to the hearts of stars. The winds themselves are a marvel, racing across the planet's atmosphere at speeds that defy imagination. These aren't the gentle breezes of a terrestrial world. They're torrents of gas, driven by forces we're only beginning to understand. The data suggests that the planet's internal thermal pulses, those bursts of heat from its exotic core, are the true engines of these gales. As heat surges upward, it triggers convective currents that whip the atmosphere into a frenzy, creating jet streams that pulse in time with the magnetic field's oscillations. It's a feedback loop of energy and motion, a cosmic dance where every element, core, atmosphere, field, moves in harmony. This dynamic system challenges our view of planets as static, predictable worlds, painting this one as a living, breathing entity in the vastness of space. The implications of this discovery stretch far beyond this single world. If its core is indeed laced with hollow chambers, powered by superionic materials, it could redefine how we classify exoplanets. Many of the worlds we've discovered orbiting distant stars, especially those similar in size and composition to this one, are modeled after our own gas and ice giants. But if this planet is a transitional object, a hybrid of planet and star, we might be misinterpreting the nature of thousands of exoplanets. Are they solid, layered worlds like we assumed, or do some harbor exotic interiors, pulsing with signals we haven't yet detected? The question forces us to rethink our cosmic census, to wonder how many other worlds might be hiding similar secrets. This discovery also raises profound questions about our own solar system. If a distant planet can challenge our models so dramatically, what might we be missing closer to home? Could other giants in our cosmic backyard, those we've studied for centuries, harbor similar anomalies, waiting for our instruments to evolve? The moons orbiting these giants, with their icy crusts and hidden oceans, might hold clues to the same exotic processes. The universe, it seems, is a tapestry of surprises, each thread leading to new questions, new possibilities, new wonders. As scientists scramble to make sense of this planet, they're confronted with the limits of our technology. The observatories that caught these signals, those faint pulses of heat and radio waves, were never designed to probe such mysteries. Yet their sensitivity has revealed a world that defies logic, a planet that seems to hum with purpose. Without these instruments, we might have missed this discovery entirely, its secrets fading into the cosmic dark. It's a humbling reminder that our tools, however advanced, are only windows into a universe that's far larger, far stranger than we can imagine. The philosophical weight of this discovery is impossible to ignore. For centuries, we've looked to the stars for answers, assuming our categories, planets, stars, moons, could contain the cosmos. But this planet is a rebellion against those categories, a reminder that the universe doesn't bend to our definitions. It's a call to embrace the unknown, to accept that our journey of discovery is just beginning. If a single world can upend our understanding so completely, what else is out there, waiting to be found? Are we on the verge of a new era in planetary science, one where the boundaries between worlds blur and the cosmos reveals its true complexity? As the data continues to pour in, researchers are racing to test these ideas. Simulations are modeling the planet's core, trying to recreate the conditions that could produce superionic ices and resonant chambers. Observatories are tuning their instruments to capture every nuance of the planet's signals, searching for patterns that might unlock their meaning. And in the quiet moments between experiments, scientists are asking the question no one dares to voice aloud. Could these signals, with their eerie precision, be more than just the product of a chaotic core? The possibility, however remote, is enough to keep us looking, listening, dreaming of what lies beyond. For now, this planet remains a cosmic riddle, its secrets locked in a core of ice and energy, its signals a whisper from the edge of our understanding. But with each new observation, we come closer to deciphering its story, to understanding a world that challenges everything we thought we knew. The universe is speaking, and this planet is its voice, a voice that might just change the way we see the cosmos forever. Just begun to unravel. This distant planet, with its pulsing core, erratic signals, and winds that scream through its atmosphere, stands as a testament to the universe's boundless complexity. Its secrets, superionic ices, resonant chambers, a magnetic field that dances to an unknown rhythm, have turned our understanding of planetary science upside down. As we stand on the brink of this cosmic revelation, we're forced to confront a humbling truth. The more we learn, the more we realize how little we know. This world, with its strange interior and cryptic whispers, is not just a scientific puzzle, it's a mirror reflecting our place in a cosmos that's far grander, far stranger than we ever imagined. What does it mean for humanity to discover a planet that defies every rule we've written? And what other mysteries are waiting, hidden in the shadows of the stars? The planet's core, laced with superionic materials that shimmer like liquid metal under crushing pressure, continues to baffle researchers. These exotic ices, capable of conducting electricity and generating heat, suggest a world that's not just dynamic but alive in ways we can't yet define. The resonant chambers, those hypothetical cavities amplifying the planet's signals, are now the subject of intense study. Scientists are running simulations to model how such structures could form, perhaps during a cataclysmic collision in the planet's youth, or through a slow, transformative process as its core cooled over billions of years. The data hints at a core that's not a solid mass, but a lattice of low-density zones, vibrating with energy like the strings of a cosmic harp. It's a vision that stretches the limits of imagination, yet the evidence keeps pulling us toward it. The radio emissions, those eerie pulses that seem to carry a message, remain the most tantalizing piece of the puzzle. Their patterns, repeating, fracturing, then reforming, suggest a process that's both natural and strangely deliberate. Could they be the result of pressure waves in the planet's core, amplified by its resonant chambers? Or are we witnessing something more profound, a signal shaped by forces we haven't yet learned to name? The question is speculative, but it's rooted in data that refuses to fit our models. Observatories around the globe are now focused on this planet, their instruments tuned to capture every nuance of its voice. Each new observation adds a layer to the mystery, a new note in a song that's been playing for billions of years. The planet's magnetic field, with its wild oscillations, is another frontier of discovery. Its cyclical flux, driven by the electric currents of superionic ices, suggests a dynamo that operates on principles we're only beginning to grasp. This isn't the orderly magnetism of a terrestrial world or the robust field of a gas giant. It's a chaotic, living system, pulsing in time with the planet's internal rhythms. Researchers are now exploring whether this dynamo could be a universal feature of transitional worlds, those rare objects that blur the line between planet and star. If this planet is indeed a hybrid, its magnetic field could be a key to understanding countless exoplanets, reshaping how we search for worlds beyond our own. The winds, those torrents of gas racing across the planet's atmosphere, are no less remarkable. Driven by internal thermal pulses rather than stellar heat, they form a feedback loop with the planet's core and magnetic field. Imagine a world where every element, ice, plasma, wind, and magnetism, moves in concert, a cosmic symphony that's been playing since the dawn of the universe. This interconnected system challenges our view of planets as static, isolated objects, suggesting instead that they're dynamic ecosystems, their interiors and atmospheres woven together in ways we've only begun to explore. Could other worlds in our cosmic neighborhood share this trait, their secrets hidden beneath layers of gas and ice? As the scientific community races to decode this planet, the broader implications are coming into focus. If its core is indeed partially hollow, with resonant chambers amplifying its signals, it could redefine our understanding of planetary formation. Most planets, we assume, form through the gradual accretion of dust and gas, their cores compressing into dense, solid masses. But this world suggests a different path, one where cavities form, where exotic materials dominate, where the rules of physics bend in unexpected ways. If this is true, we might need to rethink the origins of every planet we've ever studied, from the giants in our solar system to the sub-Neptunes orbiting distant stars. Are we missing entire classes of worlds, hidden in plain sight? The discovery also forces us to confront our technological limits. The instruments that caught these signals, those faint pulses of heat and radio waves, were pushed to their limits, revealing a planet that defies our expectations. Without them, this world's secrets might have remained hidden, its signals lost in the cosmic noise. It's a reminder that our tools, however advanced, are only as good as our willingness to question what we see. Each new observatory, each new sensor, peels back another layer of the universe, revealing truths we didn't know to look for. This planet is a testament to that process, a beacon that challenges us to keep searching, to keep listening. The philosophical implications are just as profound. For centuries, we've categorized the cosmos, drawing lines between planets, stars, and moons, as if the universe could be neatly boxed. But this planet defies those boxes, suggesting a cosmos where boundaries blur, where worlds can be both familiar and utterly alien. It's a call to humility, a reminder that our knowledge is a work in progress, shaped by the tools we build and the questions we dare to ask. If a single planet can upend our understanding so completely, what else is out there, waiting to be discovered? Are we on the cusp of a new era in cosmic exploration, one where the universe reveals itself in ways we can't yet predict? The planet's discovery has also sparked a renewed interest in our own solar system. Could other giants, those we've studied for decades, harbor similar anomalies? Might their moons, with their icy crusts and hidden oceans, hold clues to the same exotic processes? The questions multiply, each one a spark of curiosity that drives us forward. This planet, with its pulsing core and cryptic signals, is a reminder that the cosmos is alive with possibility, its secrets waiting just beyond the reach of our instruments. As researchers continue their work, the planet remains a cosmic enigma, its signals a whisper from the edge of our understanding. But with each new dataset, we come closer to deciphering its story, to unlocking the secrets of a world that challenges everything we know. The universe is vast, unpredictable, and full of surprises, and this planet is proof that we've only begun to explore its wonders. What will we find next? Will the signals reveal a natural process, or something more? The answers are out there, waiting for us to listen, to learn, to dream. If you're as awestruck by this cosmic mystery as we are, smash that like button and subscribe for more updates on the universe's greatest secrets. Leave your comments below and tell us what you think about this planet's strange signals. Could they be the key to a new understanding of the cosmos, or something even more extraordinary? We want to hear from you. Thank you for joining us on this journey, and we'll see you in the next cosmic adventure.